So, what is electrolysis? When we talk about electrolysis, in chemistry, electrolysis is simply the chemical decomposition of a substance in its aqueous or molten states by simply the passage of electricity through it. Generally, pure water is a poor conductor of electricity. That is to say, it doesn't conduct electricity. But there are solutions in their aqueous or molten states that can permit the flow of electricity through them. These solutions are simply called electrolytes, as we have said earlier on. But solutions that do not permit the flow of electricity through them are otherwise called non-electrolytes. So the question now is, what are examples of electrolytes and non-electrolytes? Electrolytes, as we have said, permits the flow of electricity through them, and examples include salts, acids, and alkalis. These are the electrolytes. Non-electrolytes, on the other hand, will not permit the flow of electricity through them. And what are examples of non-electrolytes? Non-electrolytes include sugar solution, lipids, alcohol, ether, benzene, etc. So these are non-electrolytes. So if we dip a connection rod or wire into these electrolytes and get it connected to the bulb, we'll observe that the bulb does not get lit. It doesn't light on. But if it is an acid solution and an alkali solution or a salt solution, we'll observe that the flow of electricity through these solutions will make the bulb to come on. So this is what we mean by electrolytes and non-electrolytes, and these are their examples. So, having seen the definition of electrolytes and non-electrolytes, we shall proceed to looking at the difference between materials that can conduct electricity and those that cannot conduct electricity. When we talk about conduction of electricity, then it means substances that conduct electricity are conductors. Generally speaking, metals can conduct electricity. And we have seen that apart from metals, there are other substances too that can conduct electricity. And they are called electrolytes. But the fact is that electrolytes are not this other form of conductors, that is the metallic conductors. So we are now looking at electrolytes as conductors and metallic objects as conductors, or simply we just call them conductors. So what are their differences? When we talk about conductors, that is metallic conductors, we can say that these type of conductors are simply solid metals, though graphite also conducts electricity because of the presence of one electron out of its 4 electrons, which it's supposed to use for bonding. It uses only 3 for bonding, and it has just 1 electron left. So with that 1 electron, graphite is also able to conduct electricity, even though it is not a metal. It is an allotrope of carbon, and carbon is not a metal, it's a non-metal. So it is only the presence of 1 electron in graphite that permits it to also be conductible. So metals or graphites are examples of these pure kind of conductors. But when we talk about electrolyte conductors are simply ionic substances or polar substances. So when we talk about polar substances, we talk about substances like water, for example, is polar, though not pure water. Pure water is not a conductor, but water that has impurities in it is an example of substance water that can conduct. So generally speaking, water is a polar compound. So ionic or polar substances or compounds are electrolytes. A good example of this is hydrochloric acid. Hydrochloric acid is hydrogen chloride dissolved in water. So when hydrogen chloride goes into water, it becomes hydrochloric acid. It becomes polar, or rather it is an ionic kind of compound. Sulfuric acid is also ionic and polar. So acids generally, salt, copper sulfate, sodium nitrate, all the salts, sodium chloride, potassium carbonate, they are all polar compounds or ionic in nature. So they also conduct electricity. Now, another difference is that in terms of this other type of conductors, they conduct electricity in their solid state. Metals, for example, are in their solid state, but the electrolytes conduct electricity in their molten or aqueous state, that is in solution form. Next, when we talk about conductors conducting electricity, the electric current usually is being carried by the flow of electrons. But in the case of electrolytes, as we've said earlier on, electricity is being carried by the flow of ions. So ions simply constitute this movement of electricity in electrolytes because the substances in question dissociate in solution. So as they dissociate into their ionic forms. Now, another difference also is in the mode of transmission of heat energy. In the case of this other form of pure conductors, the heat energy is being transferred by conduction. But in the case of electrolytes, heat energy is being transmitted in the form of convection. So conduction and convection are two different methods of conducting electricity through these substances. And lastly, in the case of this other type of conductors, when electricity passes through them, they don't get decomposed. Like we said earlier, that these metallic objects don't show any chemical change per se. But in the case of electrolytes, they show both chemical and physical change. As a matter of fact, when electricity passes through electrolytes, they get decomposed. So the decomposition of this substance as a result of the passage of electricity through them actually makes them conductible in the first place. So they decompose when electricity passes through them. But in the case of conductors like metals or wires, they don't get decomposed when electricity passes through them. The worst that can happen is they get hot. They just become very hot. So that is actually, these are the differences between conductors and electrolytes. That is pure conductors like the metals, and electrolytes, which are usually in liquid or aqueous states. So when we talk about conductors generally, under electrolysis, conductors have a very unique name, especially the metallic conductors. That's what we are talking about here. The metallic conductors have a unique name. And what are they called? They are simply called electrodes. So electrodes, we can simply say, under electrolysis are those metallic substances that permits the flow of electricity through them. That is to say, they are the link with which electricity enters or leaves the electrolyte. So electrodes are simply that bridge through which electricity enters the electrolyte or leaves the electrolyte. That is what we refer to as electrodes. And there are two types of electrodes. We have electrodes that are called cathodes and anodes. In electrolysis, it is good to get it clear. In electrolysis, the cathode electrodes are the negative electrodes. When we come to talk about electrochemical cells later in the course of the class, we shall get to see that cathode will be positively charged. That is to say, it will be the positive electrode. But now we're talking about electrolysis. In electrolysis, cathodes are the negative electrodes. This is where reduction usually takes place. We shall get to talk about reduction as we proceed on, not to worry. For some of us that are kind of new into this course, I know you may be wondering what is reduction. So for cathodes, they are simply the negatively charged electrode, or the electrode that is connected to the negative terminal of the source of electricity. Now for anode, they are the rods or electrode that is connected to the positively charged terminal of the source of electricity. So an anode is the positive electrode for short, while cathode is the negative electrode. So these are the features of an electrolytic cell generally, as we can see displayed on the screen. In an electrolytic cell, we can form or create an electrolytic cell by simply having an electrolyte in a beaker, as you can see displayed on the screen. When we have an electrolyte in a beaker and we have two metallic rods dipped into this beaker containing electrolyte, and then the rods are connected to a source of electricity, that is maybe to a mains on the wall or a DC current. So if we connect these rods to a DC current or to an AC current, a source of electricity, the rod that is connected to the positive terminal of the source of electricity becomes the anode. That is a positively charged electrode, while the electrode that is connected to the negative terminal of the source of electricity is the cathode. So as reaction takes place, we observe that the anode loses electron. That is to say, electron is being lost from the anode to the cathode. So electron moves from anode to cathode, as you can see displayed on the screen. The arrow diagram shows us that electron will always move from the anode to the cathode. That is, electron is being lost at the anode but being gained at the cathode. And the loss of electron is called oxidation. So that is why we say that oxidation takes place at the anode in electrolysis, but reduction takes place at the cathode, because at the cathode electrons are being received. So these are the simple features of an electrolytic cell, and we have also seen the definition of electrolysis. So with that, now I would like to have a brain teaser for us, dear students, and the brain teaser is: which of these following substances do you think will get decomposed when electricity is meant to pass through them? So which of the substances will get decomposed when electricity passes through them? We have glucose solution, hydrochloric acid, zinc rod, and tetrachloromethane. Tetrachloromethane is an organic compound, and we have discussed organic compounds in our videos on hydrocarbons. We know what organic compounds are. You should be able to know whether they are polar or non-polar substances. We talked about tetrachloromethane there. So what should be your answer? Pause now and give a deep breath and a deep thought into the question and proceed. So our answer to that question is option B, which is hydrochloric acid. So hydrochloric acid is our answer because hydrochloric acid is a substance that ionizes completely in water. It is polar, is an ionic compound, so it can permit the flow of electricity through it. Hence, it gets decomposed when electricity passes through, because it is an example of the electrolytes. It's one of the electrolytes. So, or generally speaking, acids are electrolytes, bases are electrolytes, and salts are that is their aqueous solutions, not the salt in its crystalline state, but in its solution state or molten state. So that is actually what we should know. Okay, another brain teaser for us now is the second question we have here is you're told to give two differences between conductors and electrolytes. Between conductors and electrolytes, what are two differences you can give between them? Take a deep breath, pause the video, and think about the differences, and continue the video. Okay, so we have that for the differences between conductors and electrolytes. Conductors can conduct electricity in their solid state because they could be metals, or of course, like we have seen, graphite is an example, and graphite is a solid material. It's an allotrope of carbon. So conductors conduct electricity in their solid state, but electrolytes do so in their molten or solution states. Secondly, conductors are not decomposed by electricity when it passes through them, but electrolytes are characterized with the decomposition of the substance when electricity is passed through it. So these are two differences we can talk about when we look at the difference between conductors and electrolytes. So with this, is just to give us a brain teaser so that we can wake up and as we proceed. So with this, we have seen everything about static electricity, current electricity, and we've talked about electrolysis. We've started talking about electrolysis. So as we proceed now, we shall get to see more about electrolysis. So when we talk about electrolysis, there are contributions that were made towards the topic electrolysis. What are these contributions uniquely? There's a specific contribution about electrolysis which is called the Ionic Theory. What is the Ionic Theory? When we talk about Ionic Theory, it was actually put forward by a renowned chemist, Arrhenius, and according to Arrhenius, what he said is that when an electrolyte is dissolved in water, it actually dissociates. That is to say, it splits into its free moving charged particles, which we have referred to as ions. Now, this process of these substances getting dissociated as they dissolve in water is what we call ionization. It's called ionization. So the process of dissociation of an electrolyte into its ions when it is dissolved in water is called ionization. Now, talking about ionization still, we shall get to use the following information to explain further what we really mean by ionization and also this Ionic Theory. What really is the Ionic Theory talking about? Now, when we look at the Ionic Theory puts forward to us the characteristic split or dissociation of these substances in water. So, soluble salts, when dissolved in water, dissociates into its ions. These ions could be cations, anions, or even radicals. Cations like sodium ion and aluminum ion, for example. Anions like the chloride ion or the sulfide ion, as we can see displayed on the screen. And we can even have radicals like when we have, for example, potassium carbonate dissolved in water. Its ions dissociates to potassium ion and the carbonate 4 ion, CO3 2-. When we have a salt like lead nitrate dissolved in water, it dissociates into its ions, like into lead 2 ion and the nitrate 5 ion, NO3-. So these are the ions that goes into the liquid solution as we have it. So this is actually what the Ionic Theory tries to explain. Now, still talking about the Ionic Theory and how electrolysis supports that, let us get to look at the mechanism with which electrolysis connects to the Ionic Theory.